on the accidental bidet functionality of common porcelain bowls. Recent observations have led to a noticeable difference in the accidental bidet phenomenon in various types of common porcelain bowls. Over the course of this research, we shall review our physical model, compare porcelain bowls from America and Sweden, analyze variations in personal excretion dynamics. The system that we consider is the general porcelain bowl. H is the distance between the point of origin and the water surface. R is the radius of the circular water surface. L and D are the length and diameter of the projectile. We assume that the projectile can have a density different than that of water and that it has an initial velocity of v sub 1. Lastly, we consider the projectile's angle of attack with respect to the water surface. So now that we have our model assumptions, let's consider the equations describing the projectile dynamics. To begin with, we have the initial kinetic energy. We also have the energy gained as the projectile falls due to gravity. As the projectile crosses the water surface, it feels an increasing buoyant force pushing it in the upward direction. As the water surface is impacted, waves will be created with a characteristic wavelength of lambda. Lambda is the symbol at the beginning of the equation that looks like a tiny apatosaurus. As a recap, here are the parameters that define our water bowl projectile system. Unless stated otherwise, we will consider poo 2.5 centimeters in diameter and 15 centimeters long. With our equations, the cheeks of the pilot will get unexpectedly refreshed when the following condition holds true. Without further ado, let's see how this shit flies. Our first toilet is the standard American toilet. The colored data points in the figure represent conditions for wet cheeks. The vertical axis represents the amount of water and/or the velocity the pilot is hit with. Here we can see that we either need dense poo or a high escape velocity. Now looking at the traditional Swedish toilet, we see that it is optimized for auto bidet functionality. Recent experiments support our findings. Our model lets us go beyond comparing just toilets. We were also able to look at pilot preferences. The first preference we looked at was the angle of attack. Before, we were looking at angles of 90 degrees. Here, we consider an attack angle of 45 degrees and see that smaller angles increase the splash potential. Back at 90 degrees, we look at the long poo. We see that since the long poo breaks the water surface before it can gain any real speed, a significant splash is not created. Now for the fat poo. This poo will always make a splash. Though smaller than the fat poo, the quarter-sized cannonball has a greater average wetting factor. Lastly, we have the deer pellets. These will only splash the pilot if they are ejected at high velocity. From this research, we conclude that many squares of toilet paper can be saved by increasing pilot effort to achieve high escape velocities. Any questions? Too bad, this is a DVD. This research was funded by Toilets Anonymous, Poos for Equal Poo Rights, Save the Tissues Foundation, the Foundation for Cleaner Whistles, Tissues Equal Trees, non-profit, People Pushing for Plump, Pungent Piles, and Squirrels.